Hello and welcome. So this is the second live stream for maths, and I'm going to answer some emails first, and then I've got my wife helping me out collecting your questions. So if you got questions, leave them in the chat and she'll collect them so I don't spend forever scrolling through the list to try and find everyone's question. So the first person to email me was Jasper. Jasper was asking about question 8 and question 9 of part B, the practice test. Yeah, Jasper, this is a common question I got from, a common question. He was asking about the fig tree problem where, distance traveled to the tree and how much has been done and things like that. Yeah, I did the solve. I did the solution in the previous live stream. So if you can sort of skim through the, so at the bottom of the video, and you can sort of drag along the playback, you can probably find a moment in the video where I have a drawing at the top of my page, which has a bunch of arrows and a really stupid looking tree. So you can find that one and you can see my solution step by step. But the email that I originally sent out with the attached solutions, there were some complications. So the original solution sheet was not fully correct. So I got a different answer to the original solution sheet. I just had a look on Firefly, the school Firefly. If you navigate to that, Yr7 Mathematics, and then you go term 1, and then you see on that page there, there's like the question sheet, the practice exam, and the solution sheet, which has an update. So it has the corrected solutions. I was made aware of it sometime last week, but I was a bit busy to forward that on. Apologies to everybody who had to deal with incorrect solution sheets. So that's part of the reason why I asked parents to be involved, because they would be able to pick up on some of the errors if there was any. And in fact, one parent did, which is awesome. So, so question 8, see my previous stream. There's a solution for you. If not, go into the Firefly. In fact, for my 7K class, I've actually given you a recommended Firefly bookmark. So that should help you navigate straight to it. For Jasper's second one was question 9. Krista also asked the same question via email. So Krista and Jasper, they were asking, is there a way to solve that question beyond trial and error? I don't know, actually. Trial and error is the only method that I could think of. So it's not an elegant method, but it is a method. So if you got no idea how to solve something, test it, try something else and test it. It works sometimes. Got an email from one of the parents. I'll refer to as Kim. Kim found some errors in some questions, and you're absolutely correct. So question 3, there was an error. It was definitely missing $10 in the solve. And in fact, I also encountered that same confusion in last live stream where I was trying to do question 3, and my answer was different from the solution sheet that we were originally looking at. So yes, you're right. It is off by $10, and the corrected solution sheet on Firefly reflects the new corrected answer. Question 8, yes, there was an error for that one as well. That was the fig tree problem that I solved in the previous live stream, and it is wrong. So go check out either the live stream solution or check the new updated sheet. Question 10, yeah, I agree. The wording wasn't great, and I'll pass that information on to the people who write the tests. I'm not the one who writes them. I didn't pick it up the first time I read through it, so yeah, kind of missed that as well. Sophie asked a really interesting question. She says, how to solve question 7 from part B. She got stuck. So this one here is a complex familiar, I think it was called, type of problem. And that means it's going to take a few steps to get there. Now, you might think at first that this is a simple 60% of number. But if you read it really carefully, it's actually asking something different. It says 60% of the cost of the game is a result of $90. Find the original cost. This one kind of get me a few moments to think about. I could solve it using algebra methods, but for us in year 7, we don't have algebra yet. So I have to think of another way. And the solution that I was thinking of is if I summarize this information like this, 60% is $90, almost like, you know, this is equivalent to that. If I can scale this relationship, if I can scale this down a little bit to, let's say, 20%, so how much is 20% in dollars? Then I can easily multiply 20% all the way up to 100%, and that would reflect the original cost. So here's the solve. So to go down to 20%, I have to divide that answer by 3. You can see that there. So I'm going to try and reduce it down to 20. And the reason why I've chosen 20 is that I want to find the smallest number I can. I basically want to simplify this relationship. And I want to simplify it until I get to a number which I can easily multiply up to get me 100% again. So if I went to, let's say, 40%, I couldn't multiply 40 very well up to 100, not easily. If I could, I'd divide it all the way down to 10%, but I'm not sure if I can divide that nicely as well. So I do know that I can probably divide this number by 3. I could also divide this number really easily by 3. So 90 divided by 3 would give me 3. So there's my transition. And now I want to multiply this up to give me 100. So 20 times 5 should give me 100. So if I times this by 5 to 100%, I'll times this side by 5 as well, and that should give me the original cost. So that's the solution I get. I'm just going to check my solution. Yeah, so that seems to match the new and improved solution sheet. So that's how I went about it. And before I jump into the chat feed, one last one. I sat and thought about one of the questions I was working on last time in the last stream, which was part B, question 4. So let me just, now for those of you who are much more clever than me, you probably thought of an easier way to solve it. But so the question was, sort these fractions into ascending order. Just copying them down again. And I went the hard way, which was to try and convert all of the denominators into the same number. That way I can easily compare the numerators, which one had the smallest numerator. However, when I was looking at this same problem just the day after with another student, I realized that since all of these numerators are actually the same value, you can just look at the denominators to try and sequence them, which is much simpler than what I was thinking about. So sometimes it helps to describe the maths in English, and then you can use logic. So we're looking at so if we're going to do this ascending order, which means we have to start from the smallest value and climbing up to the highest value, just like if I just did numbers, you know, ascending would be 1, 2, 3, 4, 5, and so on, where 5 is obviously the largest number of that list. What is the largest value out of all these fractions? Well, 5 pieces shared amongst 2 people, I'll get a certain value. I'll get a larger answer than if I try to get 5 pieces shared amongst 8 people. Each person's going to get less of a piece. In the same way, similarly, 5 slices divided by 55 people, my God, everyone's going to get like a crumb of whatever you're sharing. So with that said, you could just simply order them so that the denominator is the smallest. So we've got 5 over 55 would be the smallest value. Everyone would receive a very small piece of that cake. And then I look for the next biggest one, which would probably be 5 over 8. Then the next, which would be a little bit bigger, would be 5 over 7. The next one would be 5 over 5, 5 over 2. So roughly that order, I think, if I check my answers with the new and improved solutions. 55, 8, 7, 5, 2. Yeah, okay, good. So that's much easier than what I was thinking. So I overcomplicated the problem. Typical. Okay, that is my initial answers to the emails that I've gotten and correcting my, original solution from last time. So, sweetheart, any questions so far?
Yeah, we've got a bunch. So the first one I will pass on, just because I think it's a quick answer, is will we get marked down if we don't use the KEWA system? A couple of people asked that.
Okay, do we get marked down if we don't use the KEWA or the KEWA system? I think if you look on the provided solution sheet, they kind of tick the final sentence. So if you did some solving and you get an answer of, let's say, 4, it's nice to present it, therefore each person receives 4 pieces or something like that. So that keyword, I think the very final bit of keyword where you write your answer as a small sentence, that's probably important, especially if you haven't communicated that well through your working.
Okay, so we've got a question from Tyler that is, how do you divide 2 fractions, then turn them into a percentage?
Tyler, we did this on Friday. Okay, how do we divide 2 fractions and then turn that into percentage? Is that correct?
Yeah.
Okay, so this is okay. Let's do it step by step. Let's do two fractions where one's been divided. Well, we're going to do the reciprocal trick. So I can't divide this very well, but I can. If I had a multiplication problem, I could easily smash it together and create one number. Once I get there, I can then translate that into a percentage. So if I copy the question again, to do this, to convert this half of my problem into a multiplication, I need to flop this fraction upside down into, that makes it a reciprocal. When you flop it upside down, the division sign is changed into a multiplication. So multiplication now, and now my fraction is upside down. So I've just converted the problem. They're still equivalent to each other. They've just been translated into a form that's really easy to solve. So now I can just smash the numerators together by multiplication. So 1 times 3 is 3. Smash the denominators together by multiplication. 2 times 2 is 4. So now I get to this answer. To convert this into percentages, well, we use the Bygrave step. So I call it Bygrave step because Mr. Bygraves was the first one to show it to me, where you use this tool to convert any fraction into a percentage. So let's see what that answer becomes. We got 3 times 100 on the numerator gives us 300. 4 times 1 on the denominator just leaves me with 4. And I can't divide that very well, so I might use long division to find my answer. But basically, once you've solved what that is, that'll give you your answer in percentage. So if you give me a minute, I'll do some long division. Ah, can't long division very well. But whatever the answer is, that will be a percentage. Any other questions, sweetheart?
So if you could want to talk about question 8, particularly part B and the hiking problem.
The fig tree problem? Okay.
Both of those two need to be addressed.
Sorry?
So part B.
Yep.
And then there was a hiking problem as well. So
yeah. Yep, that's the hiking problem. So for those who want to see the solve again for the fig tree problem, I did the solution last live stream. So I don't know. I feel like I'm using up time unnecessarily since I already solved it last time. So if you can just go to the play bar, scroll through in my previous clip where you see me draw it. I drew something on the top of my page that looked like that in my previous live stream where I solved the problem. I may as well smash it out again. If I have to do another long division thing, I'm just going to get stuck. Let's see what the question was. So looking at question 8, the main trick, and I'm going to go fast because I've already done the whole long explanation last time, but just going fast this time, what I did is I first translated the question into a drawing. And that is to make sure that I can visualize what is the unknown, what is the answer they're looking for. And sometimes when you put all the number information into a picture, you can actually, it's just a really good tool. If you can draw things, it's often the best way to start. So here's my quick drawing. So I'm just saying, at the beginning of a walking track, so that's over here in green, the sign showed 4 4/5 kilometers to the Strangler fig tree. So that's this little red distance here, which I'm just going to put in here, 4 4/5 kilometers. So next sentence, further along the track, so that's over here, this guy in blue, 2 hikers saw a small sign which said 2 2/3 kilometers to the fig tree. So that remaining distance there. So 2 2/3 kilometers. Last sentence says, what percentage of the distance to the Strangler fig tree had been walked? Well, how much did these people walk? Well, they walked this distance here. So whatever that distance is there, if I can find out that answer, that'll be easy. If I just take this value, subtract this value, I'll get this value. Then once I've got that, if I compare how much that value is to the whole distance, that gives me a fraction. And I know that fractions can be converted into percentages. So let's quickly do that. So find out distance traveled. It'll be the 4 4/5. It'll be the 4 4/5 of the total distance removed by how much was left to walk. 2 2/3. Now looking as it is, I can't do that subtraction very well because the denominators, because they're mixed, that makes it harder. But also I've noticed that the denominators are different. So 4/5 versus 2/3, that's not going to play very nicely. So once I convert these into improper fractions, where it's just a single fraction, then I'm going to try and convert both of those fractions to be the same base, the same denominator. Then I'll do the subtraction step. So we 4 times 5 plus 4 all over 5 take away 2 times 3 plus 2 over 3. So this is just a step to try and convert these into improper fractions. And I'll just smoosh that together. 4 times 5 is 20, 20 plus 24 over 5. Take away 2 times 3 is 6 plus 2 is 8. Yes. I think that's right so far. Starting to doubt myself. So that's converted to improper fraction. Now I'm going to try and make sure the bases are the same. So I'm going to look for the lowest common factor. Yeah, lowest common factor. Can I convert both of them into 10s? No, I can't. Can I convert both of them into 15s? Yes, I can. So I'm going to do that step there. So to convert this fraction into 15s, I'm just going to triple it. So I'm going to triple the base, and I'm going to triple the top. For the other fraction, I need to multiply that by 5 on bottom and top. So I get an answer of 3 times 4 is 12. 3 times 2 is 6, 72, 15. 8 times 5 is 40. 7 take 4 is 3. So that's where I'm at now. That's now this is the value of how much has been walked. So that value goes up here. So now I've found this value. Now I've got to try and compare that to the whole distance. And whenever you're comparing something to the whole or comparing something to another, that's like math speak for fractions. That's what they do. They compare how many slices of pizza did you eat versus how many slices of pizza were there. So if I do this answer over this answer, that's a fraction. Another way of looking at it is to go this answer divided by this answer. I like that format because if I've got fraction divided by fraction, I know that I can convert that into a form that I can process. So I'll change color. Therefore, 32 on 15 divided by, so I want to take my distance traveled divided by the whole distance, but I don't like mixed format because I can't work with that. I want to find the improper form. Now, I could do it all over again, but I already did it before. So it was over here where I took 4 4/5 and I translated it into 24 on 5. I'm going to use this. In fact, I even converted it to the same base as well, but I may not need to use that. So I'm just going to pull it from here because I've already converted 4 4/5 into improper. Just going to use that again over here. So now I'm here. I'm now going to convert this by flopping this fraction upside down to reciprocal, so it changes it into a multiplication problem that I can solve. 32 on 15 times by 5 on 24. Which gives me 2 times 5 is 10. 5 times 3 is 15. Plus 60. 15 times 24. Oh, God. Five times 4 is 20. 5 times 2 is 10. 120. Yes?
360.
Sorry? You've already solved it?
Yes, I did.
All right, my wife has come to my rescue. 360. I was solving it here, and then my wife came to the rescue. So that's the 15 times by the 24. So I get to this fraction here. Now to convert that into percentage, I just basically, oh, by the way, I may as well knock out some zeros here. Since I've got a 0 top and bottom, I can knock them out, kind of like Tetris style. If you can line everything up just nicely, you can knock them away. So I just get an answer of 16 on 36. Can you still see that? Yep. And now I'll do the by-graph step, which converts any fraction into a percentage. And away you go. And you'll find your answer is roughly 44 and some remainder. That's question 8. Really fast. If you want to see that in slow motion, in all the detail, with good communication and good drawings, please watch the previous live stream. Next question, sweetheart.
So you had question 8, CF, I think, the hiking problem?
Yep, that was the hiking problem.
Oh, sweet. So you've done both parts of question 8 then? So we had several requests to explain question 9.
Explain question 9.
Oh, wait, just before you go, a quick question from Tyler that says, what's a reciprocal? Is it the opposite?
Oh, reciprocal.
Then you can move on.
So Tyler, what a reciprocal is the upside down form of a fraction. So a reciprocal of that will just be the 7, because it was on the bottom, now it's on the top. 2 goes to the bottom. So it's basically been flopped upside down, basically. And this is the tool. The reason why we have reciprocals is it's a really good way of converting a division problem into a multiplication problem. Right, where are we at? So we were looking at explaining question 9.
We'll do it in a second, but there's a couple of short questions.
Okay, short.
So Chloe asks, will the real test be about the same length as the practice test?
Yeah, 65 minutes. Okay. Same length of the real exam paper, 65 awesome. Minutes. Cool. That's 5 minutes perusal and 60 minutes for working.
Awesome. All right, now you can move on to question 9.
Okay, question 9. I presume people are asking me to explain question 9 of part B, which is the bigger one. This is the one where you had 4 divided by 2, take 6, take 2, take 8 equals 5. So this is the question 9. And the text says, insert brackets to make the statement true. You may use more than one set of brackets. Rewrite the entire equation with brackets and show your calculations to prove you've got the correct answer. Again, I kind of wish I had some other math teachers here with me, but this problem here got me, yeah, it's really hard for me to solve as well. I resorted to solving this problem by trial and error. That's basically it. But to see what the problem is, that if I actually did the BOM-DAS rules here, you would find that the left-hand side of my equation is not 5. It doesn't actually equal 5 at all. It ends up being negative 14 or 16 negative. And you've got to group together some of these elements to change the answer. So you're basically trying to work with the BOM-DAS rules. So for me, I just did trial and error. If I put brackets, oh, did I copy the question right? Yeah, I did. Okay. So the BOM-DAS, so just working with the problem as it is, I have to start here because BOM-DAS says brackets first. There are no brackets, no orders. There's no multiplication, but there is division. So this is where we should start. So 4 divided by 2, that gives us 2. And we carry down the rest of the question and see what it becomes. So 2 take 6, so whatever this is, 2 take 6 gives me negative 4. Take away 2, take away 8. Negative 4 take away more gives me negative 6. Copy the rest of the question. Negative 6 take away more gives me an answer of negative 14. So negative 14 is not equal to 5, which is the original problem. If I try and just slap on some brackets somewhere to the problem, you can sort of, the only advice I can give to you is like, there's no point of putting brackets around where the BOM-DAS rule says we should start anyway. So there's no point in putting brackets here because that's just going to be the exact same answer because we have to start here anyway. You might think, okay, well, what if I put brackets between here and here? That's what I was thinking, and then I did the solve, and I said, oh, I'm getting a bit closer and a bit closer. Maybe I can put some more brackets in here, more brackets in here, and more brackets in here. If there is a better way of solving it, I would love to know, but that's the only the solution I could think of. Oh, and each time I put on the brackets, I did the solve again and see if I can get my answer closer and closer to 5. That's what I did. So just, you know, it was an iterative process. Next question, if there was one.
Yeah, definitely. So we've got requests for both question 10 and question 11.
Question 10 and 11.
Yep.
Question 10, 10, 11, I presume, comes from the part B. Question 10, I solved in the last video live stream. So again, guys, go and see that video, please. I think the thing that makes question 10 confusing is that they're saying that both A and B are negative integers. Yeah, so the solution proposes that, oh, I've used up most of my data. Ugh, my phone. Might have to wrap it up pretty quick. I did solve it last time. So that's all I'm going to say, only for the sake that I'm burning through my mobile data, which I'm streaming through right now. Question 11. Don't know if I can solve that very quickly. Question 11, part B. Certain triangle, shortest side is half the length of the longest side. And the third side is 3/4 the length of the longest side. Yeah. Sorry?
Sorry, go ahead.
Well, my first strategy for question 11 is, again, I'm going to want to draw a picture. So I know that triangles can be even, they can be two sides even, one side odd, and I can have all sides different lengths. So these are some triangles I should be thinking about. And so reading the question again, the shortest side is twice the length. Sorry, the shortest side is half the length of the longest side, and the third side is 3/4 of the other side. So I'm probably thinking of something that looks more like this than the other two. The perimeter of the triangle is 27 centimeters. Calculate the length of each of its sides. All right. So here's my triangle. And the trick here, guys, is to don't worry so much about trying to make the diagram. Don't try and make the diagram perfect, you know, a perfect representation in real life. This is just enough to get us thinking. You don't have to make it, you know, you don't have to get your ruler out and try and make this twice as long as the other one. Just as long as you've got a rough idea and slap the numbers on top. Shortest side, which is going to be this one. So I'm always returning to the question. That's part of my thinking here. That's part of my process. So this is my short one. In a certain triangle, the shortest side is half the length of the longest side. Okay, so how to represent that? Well, maybe let's give them a name. So longest, shortest, and then so I've decided to name them according to the actual words from the problem. You could probably use like A, B, and C if you wanted to. So again, going back to the question, the shortest side is equal to half the length of the longest side. So shortest is equal to a half times the longest side. And the third side is 3/4 the length of the longest side. Okay, so that's my thinking so far. The perimeter of the triangle is 27 centimeters. Calculate the length of each of its sides. Well, perimeter means the total boundary. So whatever that length that would be, if you walk the entire boundary, how much would that be? That's called the perimeter. So that's going to be this length here, plus this length here, plus this length here. And I can probably express that just by using English. So the shortest side So that's what I'm getting so far. So rather than just saying short side, third side, and longest side, I actually swapped them out because the question told us roughly how much they were. So I decided to use this information instead of this information when I did my sum. So that side of the triangle plus that side of the triangle plus that side of the triangle gives me 27. Now that it's in this form, I'm realizing that I could probably gather a lot of these terms together since everything's just longest. Yeah. So this is half times longest plus 3/4 times longest plus 1 times longest. So maybe I could sum them together, or not sure if factorizing is a thing that we do in grade 7, but I could probably rewrite this as a half plus 3/4 plus 1 . So this is a way that I could gather like terms. Since everything has been multiplied against the longest, so I put it over here, and then I just took all the fronts, half times, 3/4 times, 1 times. And since all these things are plus, that's why I've plussed these 3 items together. I don't think many of us in the live stream are going to understand what I just did there. This is maybe Yr7s do this sort of thing, but that's where I would keep going. Then I can smash these fractions together, which gives me a single number times longest equals 27. And from there, I can probably guess what the longest side actually is supposed to be. Then from there, once I know what the longest value is, I can then substitute it into here. So half times whatever that number is gives me this side. And 3/4 times that longest value would give me the answer for this side here. So that's how I could find all 3 sides. I'm not going to smash out the numbers just for the sake of time. Sorry. Any other questions?
Just a brief one. Will the test be the same amount of working as the practice test?
Same amount of working. Yeah, I looked at the actual test, and it looks about similar. So you got a part A, which doesn't require a lot of working. If you see in the practice test where part A is just like 1 mark for a lot of the questions, that means that you're not expected to show working for those problems. For part B, where things will take maybe 2 or more steps to do, then you'll have to be showing your working then, especially.
Yeah, and do you know how many test questions there'll be?
How many questions there'll be on that test? I could look it up, but I don't think I'm allowed to say that sort of information. I don't feel comfortable telling that much detail. Sorry.
How many word problems will there be, like question 8 and question 9?
I don't know. Proportionate-wise, it looks like it's a very similar proportion to what you just experienced on the practice test, where you have a part A, which is a lot of very simple ones, and that took you a few pages, and then part B has quite a number of worded problems.
Very importantly, Thomas says that you're awesome.
Thank you, Thomas. That's not a question, though.
Spelling your name incorrectly.
They're spelling my name wrong.
Shout out to Connor and Jasper for correcting.
Thank you, guys. Thank you, Connor and Jasper, for correcting people spelling my name. I try and spell my students' names correctly. I expect the students to spell my name. Yep.
Jasper wants to know if you can make posters for the classroom.
If I can make posters. I'm actually going to work on that. I'm going to try and get some of those scientist posters printed Monday, Tuesday. So when we get back, I'm going to see if I can get it done and put them up.
I think that's all the questions I have.
Okay. All right, well, I might call it quits for now. It's been about 40 minutes of a live stream, and I've probably blown through all my data on my phone. So thank you, everybody, for stopping by. If you've got further questions, remember that Ms. Pereira and Mr. Biograves, they often run math tutorial sessions. They do it Tuesday after school. They do it Wednesday at lunchtime. They do it in the room MSN1. Obviously, for my kids, where we're doing our test on Tuesday, that's not really an option. That's part of the reason why I'm online here, so you can ask me if you have any further questions. But I'll catch you guys in math class. See you guys later. Bye.